The purpose of the Metrix Digital Proximity System, or DPS, is to allow customers to reduce their spare parts inventory and increase the reliability of their proximity probe systems. This video will demonstrate that the Metrix DPS has a full 80 mil range in both an open and a tight situation. We will demonstrate the linearity of the Metrix DPS using a static calibrator with a 4140 steel target, a standard Metrix MX8030 probe and extension cable, a multimeter to display gap voltage, and Excel to record our data. We will plot 10 mil voltage increments from 10 mils to 90 mils. The proximity probe scale factor is 200 millivolts per mil. So a 10 mil change will produce approximately a 2 volt change in voltage. You will notice that the line created by the points is very straight, and the slope is very close to 200 millivolts per mil, which is well within the 200 plus or minus 10 millivolts per mil range required by API 670. The incremental scale factor, the slope between points, is also between 190 to 210 millivolts per mil as required by API 670. We'll now add a carbon steel fixture that will impact the proximity probe readings. The normal counterbore for a proximity probe is at least one probe tip diameter, which is represented by the outside diameter of the steel fixture. The probe will occupy the hole in the middle. However, to force a tight view situation, we are going to use a 0.5 inch or 12.7 millimeter counterbore. You can see the 8 millimeter probe has a very tight side clearance. Without making any changes to the DPS, we'll mount the fixture on the static calibrator and run another probe calibration check. Notice that we place the probe tip and fixture parallel with each other by first having the 4140 steel target meet up with the probe, and then we gently rotate the fixture so it is in contact with the 4140 steel target. For the first 10 or 20 mils, we will hold the fixture so it does not rotate. We'll record DC voltages in 10 mil increments as before. As we measure the 10 mil increments, you will notice that the new line is not straight. The curve starts to bend downward at 50 mils, and the incremental scale factor is outside the 200 plus or minus 10 millivolts per mil range. This is not acceptable. Fortunately, we can change the characteristics within the Metrix DPS to create a linear and accurate system. We will connect the DPS to the computer using a mini USB cable. We'll use the Metrix DPS software to change the configuration from MX8030 probe series as seen on the Get row. Using the Send row, we can change the MX8030 probe series to TightView. After we have selected MX8030 TightView, change the transmitter to position, and the range to 10 to 90 mils, we can then send the new configuration to the DPS. Notice the yellow banner states the configuration is being updated. After the configuration is sent, you can see the new configuration in the Get row in the DPS software. The software will ask you if you want to print a new label. We will select Yes. You will see the new information has been added, and you can add your own notes to keep track of the changes. You can then print out the label and put it on the DPS. For this demonstration, we will not print the label and select Cancel. With the new TightView configuration loaded, we are able to rerun the calibration check to physically see if the new configuration was successful. As before, we will record DC voltages in 10 mil increments. When we adjust the micrometer in 10 mil gap voltage increments from 10 mils to 90 mils, you will notice that the line created by the points is now straight. You will also notice that the incremental scale factor is between 190 and 210 millivolts per mil. This video shows the power of the Metrix Digital Proximity System and its ability to go from an open system to a tight view system with only changing the DPS configuration. Also of note is that the Metrix Tight View system has the full 80 mil linear range. For more information, visit us at our website. Thank you for watching this video.